Question 297, serialize and deserialize binary tree from LeetCode. Let's jump to the question. The question asking us to design an algorithm to serialize and deserialize a binary tree. There is no restriction on how your serialization or deserialization algorithm should work. You just need to ensure that a binary tree can be serialized to a string, and this string can be deserialized to the original tree structure. So this is a design question that is asking us to build two functions. One is for serialization and the other one is for deserialization. And what we're going to do, we are going to, in the serialization function, we are going to build a function to serialize a binary tree data structure to a string data type. And if a string is given to us, we should deserialize it to the binary tree data structure. And when we talk about the binary tree, first thing comes to our mind is traversing the tree. We have two main methods that we can traverse the tree. One is BFS, and which is going to be level by level, and the other one is DFS, right? And in DFS we have three different methods. We have in order, we have pre-order, and we have post-order. For solving this problem, for serializing this binary tree, like for the serialization function, what we are going to do, we are going to use pre-order traversal, and we are going to build an array, and we are going to traverse the tree and add the node's value to the array, and then we convert that array to a string. Let's jump to the code and see how we can do that. In this code, the first thing that we are going to do is to build the serialization function. The only thing that is given to us for the serialization function is the root of the tree. So we are going to use this node to traverse the tree. As you know, when we have a tree node, it has in the constructor we have, it has value, it has a left node, and it has a right node, which by default it's none, right? So what we are going to do, we are going to make a list, an empty list, and we are going to use a helper function to traverse the tree. We pass the into like the root that is given to us as an input to the helper function, and the helper function, using pre-order traversal, it will traverse the tree and add the values as a string to the list. And for the values, when it's not none, we are not going to just return it. We are going to add a non-value to the list as well. And after we are done with the traversing the tree, we are going to join the values that we have in the list to return a string. So the output of this function is going to be a string. And for the deserialization, what we need to do, a list is given to us. So this is the input of the deserialization function. So we are going to use a helper function for this one as well. But what we're going to do, now we have a list, right? And we need the actual input is a string, right? The input is a string, and we need to make it as a list, right? So at this point, we convert the string to a list. So now the output of this data is going to be a list, right? And then we pass this list to our helper function, and let's see what happens here. In the helper function, we should build a tree from the list that is given to the helper function. What we are going to do, we are going to get the first value that we have in the list at index 0, and build a tree node using this function that we have here, this class that we have here. We build a tree node, and we pop that value from the list that has been passed to the function. And then we are going to call the helper function for the left node and right node until we have nothing in the list left. And for dealing with the cases, the value in the list is none, we are going to just when it's equal to none, we are just going to pop that value from the list and do nothing. We don't need to do anything because we don't need to build any node or anything. We're just going to pop that and return it. And this is how we are going to serialize and deserialize a binary search tree and a string. The time complexity is going to be like linear for both of them, because we traverse the tree at this one only once, so we traverse the tree like every single um, node in the tree, and in this one we traverse the list only, like every single item of the list only once. So the time complexity is going to be on, and the space complexity is going to be on, because we store the values in result here, and for the tree we store them at the root. Thank you.